Hello everyone. Today we're going to be talking about adjacent angles. In our lesson today, when you hear the word adjacent, think of this meaning next to. Anything that is adjacent means next to. So if I have Sam, that's a person. If I have Alice, a very good drawer, by the way. And they're standing next to each other. You could also say that Sam and Alice are adjacent to each other, so it just means next to. If I took a second and just drew you a quick little picture, I'm just going to draw you a diagram here. Alright, so I'll call that F. There's E. There's G. And there's H. And if you had to determine, there's one of your angles, and there's your other angle. So if I asked you right now to determine if your angles were, if these two angles, I'll just take a second and I'll highlight our two angles. There's a highlighter, I think. So here's your first angle. There's EFG, and then if you also had angle GFH, if I asked you to determine if these were adjacent, there's three criteria that you must be observing. The first criteria is that do they have a common vertex? And the common vertex here would be F. That didn't work as well as I was hoping to. Let me try again. I really was hoping that would be more of a highlighter than a marker. Let's see if this works. No, that's more of a scribbler. So I'll just do that one more time. Your common vertex is F. The next thing is it needs to have a common arm. So your common arm is this arm right here that's shared by both of your angles. So your common arm would be GF. Ooh, that's fun. I can't write like that for too long. Or the other direction would be FG. So that'd be your common arm. The next question you need to ask yourself is, do the two angles lie on the opposite sides of a common arm? So there's the one angle, and there's your other angle, and they're both on opposite sides of your arm, GF. So if you look at this, you could say that angle EFG and angle GFH are adjacent. ADJACENT. Sorry, I gotta say it out loud so I spell it properly. And don't forget that when you write your angles, that the middle letter is where your vertex is, your vertice is. So there is, that's why F is in the middle. So I'm going to go to my next slide. So, common question you could be asked are these angles adjacent? So, the first thing you need to ask yourself is there a common vertex? Is there a common vertex? The answer is yes, there is a common vertex. Where is that common vertex? It is B. That didn't work so well. Let me try that again. B is our common vertex. So you can say that B is the common vertex for that one. Excellent. Next, is there a common arm? So with the common arm, we'll take a second and we'll look. Is there a common arm? And there it is right there. So I meant to use the highlighter. There's our common arm right there. So our common arm would be yes. Oh, I'm going to use a marker. Okay, and then that would be BC, or you could also write it as CB, depending what direction you're going in. But mostly, it does have a common arm. Finally, the last question you need to ask yourself: does our two angles lie on opposite sides? So do they lie on opposite? I don't like this website for writing as much. Sides gives me a bit more room and the ability to put in bigger pictures, but I can't write as nicely. Sides of the arm. So our two angles on the opposite sides of the arm. I'll take a marker for a second, and here's our first angle right here. Here's our second angle right there, and they're both on either side of our arm. So the answer is yes to that. So after you figured this out, you must write a final statement. So I'm just going to draw a line here just so it kind of separates up my work. So a final statement, you always start with a therefore symbol. So this is a therefore symbol. It's the three dots, just like that. They usually look like a triangle. Mine's looking already messy. It's just a little bit tricky to use this program. They usually look like a triangle. So therefore, those three dots mean therefore. Angle ABC. So angle ABC is adjacent to ADJ ACENT. So I just want to make sure I spell it properly. To angle, and what's the other angle? So don't forget to write it in proper format. CBD, with B being the vertex, so that'd be CBD. And do not forget that that symbol right there means therefore. So you need to write that symbol to say therefore, and that's a required part of this. So that means therefore. All right, complete the statements to determine whether the angles MLN, so where is MLN? I'll just take a second, we'll highlight that. So MLN and angle NLK are adjacent. So first thing we do is we look at a common vertex. So does it have a common vertex? Does it have a common vertex? Yes. What is it? That common vertex is L. Next thing, does it have a common arm? Yes. It's segment NL or LN, depending which direction you're moving. But yeah, that's good. And finally, does it lie on, do our two angles lie on opposite sides? So do they lie on opposite? I might try to get myself a stylus. This is painful. Sides. Can't even draw dots. There we go. Lie on opposite sides. And this is where we take a second and look. Okay. So we have the one angle, we have the other angle, and they're on the opposite sides of our common arm. So the answer here would again be yes. So we need to write our final statement. So this, again, you start with your three dots. After your three dots, which mean therefore. So therefore, angle MLN is adjacent to ADJ ACENT to angle NLK. Beautiful. All right. Next example. Angle ABC and angle CBD are adjacent angles. Angle ABC is 45 degrees. Angle CBD is 105 degrees. Draw these angles and calculate their total sum. So I'm going to start with angle ABC. I know 45 degrees is a smaller angle, about half of a 90. So if I take a second, I can just take a second, there we go. I'm going to label my parts of it now, and B is our vertex because it's in the middle of A, B, C. So I write B down here because I know it's the vertex, A, and C. Perfect. So the next thing I do is I can draw a little angle symbol, and I could label it as 45 degrees. Next, I'm drawing them. So angle CBD. So we know B is the common vertex, and we can see that C is a shared point on our angle. So we know also that 105 is greater than 90, so you're going to have to visualize it as greater than 90, so I might just draw it down like this. There's angle D, or point D down there. That's really messy. I'm just going to undo that. Ooh, sorry. I'm going to undo that just to clean it up a bit. That's D right there. We are told that that angle right there is 105. I'm tilting my computer on its side to draw this. You would laugh if you saw me right now. So we have drawn these angles. Check. Next, we need to calculate their total sum. And the reason why I drew them together is because it tells me that they're adjacent angles. So now I need to figure out their total sum. What is this angle right here, that total sum? So I say that it's 105 plus 45. And I can do that to determine it's 150 degrees. Boom. Example 3, done. Example 4, name all the obtuse angles that are adjacent to U, Z, Y. So there's two pieces of information that are important in this question. First of all, where is U, Z, Y? So U, Z, Y is right here. That's the first piece of information that's important. The second important piece of information in this question is the obtuse angles. That's another important piece of information. So remember, obtuse angles are greater than 90, but less than 180. So I'm going to start by looking at a couple things. Number one, where is our shared vertex? So right here, we got our Z is the shared vertex, or it's common. So we know the shared angle is Z, it's shared by everything. So the next thing we need to figure out is we've got two arms that could possibly be used for this. We've got arm UZ and arm ZY. So I'm going to take a second look. So is our first angle, and I'll just kind of drag it out here, that angle right there, UZB, is it adjacent? Yes, it is. But is it obtuse? No, it is not. So as a result, we cannot use UZV as one of our angles. However, if you look here, you got UZW. Is it greater than 90 degrees? I can look at that by estimation. Yes, I know what it is. So we have angle UZW as one possibility. We can also again look from our shared arm. We have UZX. Is UZX greater than 90? Yes. Is it less than 180? Yes. So we also could use angle UZX. So there's two. The next thing we can look at is we need to look at what angles are shared with ZY. So there's our next arm. So the first one I can see right here is this angle right here. Let me just press undo a couple times just to get rid of some of this messiness. The first one I can see is YZV, that angle there. So that angle right there. Is that angle less than 180? No, it's not. However, if you think about it this way, think about it as that angle right there, it can be considered to be obtuse if you look at it that way. And the other way you can think about it is it does have a shared vertex and shared arm, so yes and yes. So our first angle, if you think about it in this format right here, is we can look at and write down, so angle YZV as 1. The next one we can look at is YZX, that angle right there is also obtuse. So, and angle YZX, and the last one would be right here, and that would be, and, sorry, I'm trying to save room and I can't fit it all in, that little symbol means and angle YZW. So if you're asked for a nice, neat, and I'll try my best to write neatly here, so the obtuse angles would be angle UZW, angle UZX, comma, angle YZV, comma, angle YZX, and angle YZW. Ugh, that one just does not want to write. Try one more time. To be better, are adjacent to and obtuse angles that are adjacent to angle UZY. I hope that helps you out. I think I've done examples that kind of help you with all the practice I've given you. Good luck, and I hope you're all doing well. Take care.